Hello guys, welcome to the ASTRO. So in this physics tutorial, you are going to learn the overview of time dilation concept in a special theory of relativity. So here we have equation for time dilation, this equation, and it can be read as delta t equal to delta t naught divided by a square root of 1 minus beta square, and where beta is v by c, and also beta can be written in terms of gamma. The delta t is measured in, say, moving frame. So it's moving frame time measurement, and delta t naught is called proper time. Proper time or time measured in a rest frame of events. Okay. So this equation we have to derive using a very basic assumption in STR called constancy of speed of light. So here we will assume that, so here you have assume that a speed of light c is constant for everyone. Okay, constant in all inertial frames. Okay, so for deriving that equation intuitively, we have a benchmarks that has been set up here. Okay, so here we can see that from rest frame perspective, it's called a rest frame perspective. Okay, so here suppose that we have a laser, say you have a laser beam, and from at E1 point it goes to E2, and here M1 and M2 are, say, plane mirror. So here M1 and M2 are plane mirror. So from the faces of M1 and M2, the laser pulse bounces back from E1 to E2. Okay, so and the distance between M1 and M2 is L. Okay, so this is the distance equal to L. Okay, so now calculate time at rest. Okay, so t in a rest frame equal to, you can call it as L by c for going up and L by c for going downward, because c is same and L is also same. So you can write this as 2 L by c, and you can write as t rest equal to 2L by c. Box it and call it as a equation, say, 1. Now analyze the same event from a moving frame. So imagine that the whole setup moves with velocity v in, say, x direction. Okay, so what a person is standing here will observe that as it moves, it will see that the portion, let us call it as a E1 prime, then E1 double prime and this called as a E2 prime. Okay. So, it will see that the light goes at an angle theta. Okay. So, this is the speed of light and this goes at an angle of theta and this is going with velocity v. Okay. So, here you can write as, if this is the speed of light c, then you can write c cos theta. Okay. So, this is a component c cos theta and that will be c sin theta. Okay. Now, here is a very intuitive way to derive the time dilation from this basic picture. Okay. So, as the light pulse goes from E1 to E2, it has to again come back to E1. Okay. So, same thing will be happen in the moving frame also. Okay. This is your moving frame. So, in this frame it will again come to E1 double prime at point. Okay. So, what will be condition? So, condition will be like that. So, condition to hit light pulse at E1 double prime is that your V horizontal should be equal to c and then cos theta. Okay. So, from there what else you can write? You can write V by c equal to, you can write say V by c equal to cos theta, and similarly you can write cos theta equal to 1 minus sin square theta. Okay. Sin theta equal to root under 1 minus v square by c square. Okay. And call it as equation 2. Diagram you can write sin theta equal to, you can write sin theta equal to, this call it as a O. So, O E2 prime by E1 prime and E2 prime. Okay. So, what is your O E2? So, O E2 is basically your time taken to cover L. Okay. So, this is your L. Okay. So, this is your L, and E1 E2 prime is time taken in moving frame. Okay. So, let call it as a distance, and call it as a distance say d. Okay. Call it as a d distance. Now, so you can write this should be d. So, then you can write L equal to c and then t raised by 2, then divided by. So, you can see that this hypotenuse is longer, so time will be longer. Okay. So, time will be different for that. So, you can write c and then t moving by 2. So, from there you can cancel c and 2. So, what will be left? So, will be left out as sin theta equal to t rest by t moving, or you can write as more intuitively as 1 minus v square by c square equal to, you can mark in terms of t rest in terms of time interval and delta t moving. Okay, so from there what you can deduce that delta t moving equal to delta t rest divided by 1 minus v square by c square. So basically you can also write as a delta t equal to delta t naught root under 1 minus v square by c square, or you can also write in terms of your beta parameter 1 minus beta square, and where beta is called velocity ratio v by c. So this is your expression. So this is your final expression you got. So, I hope you got the idea that how to derive time dilation using the basic assumption that speed of light is constant in all frame of references. So basically it tells us that if you look at this equation, then you can see that the beta is v by c, so it's always less than 1. So delta t is greater than delta t naught. So it implies that the time measured in moving frame for the same event happening in a rest frame is larger. So this is the how like time get elongated in your moving frame for the same event happening in your rest frame. So this is the concept of time dilation. I hope you got the idea. Thank you.